they're good at that.
Okay, we're back, we're live, we're here. It's 3 o'clock on a Thursday. And guess what? We have Jim Alberts from Hawaiian Electric to talk about Hawaii, the state of clean energy, a future of distributed energy resources. And that is an issue of great import lately and of great interest all around town. One of the reasons is it's going to be involved in this APCES, which is actually something else now, ASPIRES or something. Let's try to extend both of those acronyms. Anyway, welcome to the show.
Thanks, Jay. Appreciate being here. It's always good to be here.
Great to have you here. I feel that we can have a good conversation and I can learn and the public can learn. And that's why we do a lot of energy, because we want them to know. We think the public needs to know about this. Not only the arguments made, but the real science and technology and the reality in our transformation to clean energy. So we open it to you. If you want to ask a question, make a comment, whatever you want to do, you can do that, and Jim will answer you. Try ThinkTech HI. That's our Twitter handle, and we have a big Twitter feed monitor here where we can see what you said. So I guess the biggest thing on the deck seems to me on distributed energy resources is the program used to be Asia Pacific Clean Energy Summit. Now it's Asia Pacific.
Well, there's an overarching theme of resiliency and innovation, and the Clean Energy Summit is a sub-part of that.
Right.
So I think they all tie together really nicely because we live here in an isolated situation on an
Ted
island.
Ralston, folks, host
So
of our
the notion
show.
of resiliency is critically important for us. We don't have anybody else to rely on but ourselves in order to generate electricity. And we have to focus on that first, I think, to maintain our way of life, our lifestyle, and our economy. And then we can focus on innovation. So we have to work on both of those.
Why are you worried when Brent crude went to $44 today?
Why am I worried?
Yeah.
Well, I think it's great for customers when we see oil prices go low, but I don't want us to lose our resolution to achieve a clean energy future. So we know one thing for certain, that even if oil prices are low, they won't stay low. So even though it may look economically attractive to stay where we're at, we have to push forward.
Absolutely. So here we are, and we've reached a point in our evolution. We started out, I love to talk about we started out in 2008. It wasn't the first beginning, but it was the formal beginning of the Clean Energy Agreement, in the fall of 2008. And 2 years later, it was the Cheap Energy Initiative, from the clean energy to the cheap energy. I mean, and if you go out on the street and talk to anybody on the sidewalk, you say, what do you think about clean energy? And you say, I want it to be cheap.
Right.
And nobody knows how to get there, but that's what people say. And I think that's a question that's got to be wrestled with, because there's a grand inconsistency in spending tons of money on new technology, new devices, new connections, in order to achieve clean energy and expecting that that's going to make it cheaper. That's not necessarily going to make it cheaper.
No, that's right. And, we have to pay attention to what our customers want. So last year there was a survey done by University of Hawaii, and it polled a large number of people, and the results came out and said the number one driver for people is cost and affordability. And I think all that tells us from that perspective is people are looking at it from their household budget perspective. They're not thinking about this as just their electric bill. They're thinking about it total cost, all in. And at the Hawaii Clean Energy Day, it was even striking to have a room full of energy experts, and affordability and cost still came in at the top or near the top of everybody's chart. So I think we can't lose focus on that.
No, we can't. On the other hand, I would say that the people in general don't understand that in order to create a new system, you have to spend the money. And clean energy is not necessarily cheaper. So when they demand cheap, that may not be a realistic expectation or demand, especially if oil stays low.
No, and I think that's a great point. It may not always be cheap compared to other places, just like everything else here, it's more expensive. But if we want stability and resiliency on the islands, we're going to have probably something different than what most of the mainland places have. If they take risks and they lose a power plant somewhere, They can go out on the spot market and buy power from somewhere else on the transmission system.
We can't do that.
We don't have that option. So we really are gonna have to plan those futures, and I think what we'll have to do is sit down and say, these are the alternatives, and these are the costs for each of the alternatives, and make sure people have the option to weigh in on those choices, so that everybody makes that choice with their eyes wide open.
So, we're in a situation now where Hawaii, more and more it occurs to me, that Hawaii has got to, and that means Hawaiian Electric, has got to design its own. We got to make our own special brand to be consistent with what the customer wants, consistent with, cultural requirements and expectations, consistent with cheap, consistent with clean, the environmental view of the matter.
Right.
There must be 4 or 5 different vectors all pushing, and what they must yield, it's not easy, is a brand new Hawaii-only special kind of arrangement, our special mix, our special product. And that isn't easy, and it isn't cheap. But, so tell me in a word, what's happening with that, and what are the challenges about doing that?
Yeah, the challenges here are we're a very unique ecosystem, just as you've described, almost in a self-sufficient way, island by island. And each island has its own unique set of renewable opportunities. The Big Island, Hawaii Island, for example, with geothermal capabilities, already is at 50% renewable base. Maui has a wind opportunity. And Oahu is primarily a solar opportunity right now with some wind. But we really need diversity across all 3 islands, because in our future of 100% renewables, it's got to be diverse. Now, the reason I say that, it just makes common sense from a risk management perspective. Because we are in the middle of the ocean, we're going to have to provide that power. And my personal perception is, no matter what anybody would tell me about willingness to accept less reliability, frequently I hear from customers they want high reliability and high power quality. We're in the digital age. Even as I look around this room and see all this equipment, it relies upon steady power at steady power quality with the right frequency. So we have to move ourselves that way. The thing that makes this difficult is technology is coming quicker and quicker, and if you commit too soon to any one technology in a major way, in a few years, the new technology comes through and it's even cheaper and more efficient.
So how do you deal with that? That's a hard one, and that happens across the board on so many areas where technology is in play. How do you deal with that on a large scale?
Right, I think you have to depend on the opportunities that are here in the islands first, because if they're local and they're natural, you can take advantage of those opportunities. Some of the newer technologies, like new solar technologies and new storage technologies, those will probably get deployed in markets even before they get deployed here, so we'll get the opportunity of seeing how effective and efficient they are somewhere else before we deploy them here. There are lots of places much bigger than us that have a lot of money to spend on research and design and development. We're not in that position today, so we rely on reaching out to everybody. Today we have coordination with island nations around the globe, and we're talking about all the technologies they have and they use. So I think it's that coordination and staying together that will make it work.
Let me go to 2 points that come to mind. Number one, we had Red Butler on the show a couple of hours ago today. He's the director of HIGP, the Hawaii Institute of Geophysics and Planetology. Okay. And he talked about undersea cables, not necessarily electric, but communications cables. And he's talking about the fantastic changes in technology that apply to these cables. And they carry their own ability to communicate with both ends. So if you wanted to know how a piece of cable was doing, you just put a little device on there, and it'll tell you. It'll shoot that message out anywhere you want because it's already on a communications device. So that suggests that there must be a model out there, or maybe you're working it already, where we have this device, the black box, if you will. It sits in or with my inverter or my house in general. It doesn't have to be photovoltaic.
Right.
It just talks to you at either a regional level or a home office level, and it tells you whatever would be helpful for you to be most efficient in delivering power or taking power,
Right.
whatever the case may be. And so, I mean, this is really sexy stuff. Last hour, we talked to Keck Observatory, and they came up with an app that tells you the sky wherever you look. And I say, wow, who would have thought? But where are we then in the black box? Where are we then in a box that communicates back to the home office and a box at the home office that takes that and processes it and makes some sophisticated algorithm decisions
Right.
about how much power to take and to give?
All right, well, I'll peel that back in layers. So the first layer that we've spent a lot of time on already is looking at inverter technology by itself. So the inverters are on the home, they convert power that you can use in your house. The inverter manufacturers have been busy working on that technology to advance it. And we've been working with them, Enphase in particular, having access to their data, their information, and being able to make those inverters as smart as they can be without being integrated into the grid is a first step. Now, we think that can add a lot of value. Then you get to the next layer where all of these inverters are networked and they start to talk to each other. And they can actually act kind of like a virtual
Talk
power
about
plant.
mesh.
A mesh network.
Everybody talks to everybody.
Yep. So this whole idea of an integrated grid is so critical for our future because with renewables and intermittency, the response time or the reaction time for the system to react to those events has got to be extremely fast. So the networking of this equipment has to be reliable and high speed. And then when you get to that kind of that outer layer where you're really looking in at this, hoping for an automated solution, a market-based solution, you would have a system that would manage that process and it would manage the settlements and the pricing, and it would make sure.
Pricing, I like that.
Yes.
It's like the toll highway.
It
More
would.
cars, higher price, fewer cars, lower price.
You know, there's some examples of it today in the mainland where you look at the transmission systems and the way they operate power in and out of the transmission grids there. They have settlement systems and they know how to operate that real time. So some of that technology, there are pieces of it everywhere, but bringing it together all in one place, I think, is a unique opportunity for us here.
Right, and to have it, our special sauce, the way we want it to satisfy all the vectors, which won't be easy, but it'll be really a thrilling experience.
It will. Now, I will say, we're also, like I said before, we're in an environment where we can't take a lot of risk either, because people depend on electricity to power the economy.
Whole society, everyone.
If the power goes out, the economy shuts down. So while we really want to innovate and push hard, we still have to pay attention to that resiliency factor and make sure businesses are strong.
So how do you do that? I mean, for example, in terms of the inverter, a lot of people, I think most people bought their inverters from the installers. Those inverters may be getting old. Those inverters may not be up to the level of technology that's available now. Those inverters may not have the communication functionality that you're talking about, that I'm talking about.
Right.
So how do we replace them, and who pays for that? I mean, to me, in the near term, well, in the intermediate term, we're going to have to replace all those things with modern black box telecommunications devices that do the mesh network, that talk to you and listen to you. And we're going to have to, find a way to get them, design them, get them, install them, integrate them, activate them, whatever it is.
Right. We'll definitely have to do that. The first thing we have to do, though, is fix this going forward so that any new project that goes in has the latest technology that can be updated. One of the things we found that's probably the most challenging is if the solar companies today, if they don't have remote capability to connect to that inverter, they actually have to send somebody out to the home and make the adjustments to the settings. So it's not very efficient for anybody.
And costly and delay and all that.
So the new requirements going forward, we have to fix that as soon as we can. And it's part of the DER docket that we've got open with the commission now.
Summarize the DER docket.
Well, the DER docket, in short, there were two phases. Phase one was to address the immediate near-term urgent issues. And the urgent issues were, fixing what's going on with the queue, making sure that we're addressing the technology issues to make sure we have standards in place and looking how we be more proactive in our approach. And I'll give you one example there. Switching from, this is a technical term, but daytime minimum load is a measure for whether people can get interconnected or not, to a new notion of hosting capacity. And for those of who are watching that went through the RSWG process, it's a lot like the proactive approach, where we look out and we do a study of every circuit, and we say how much capacity, solar capacity, can be on the grid without upgrades. So it will speed that up tremendously if that gets approved and we have the right agreement around that. Somebody can look at their circuit and say, there's capacity I'm going to apply, it'll move through much quicker than doing it after the fact. So the second phase really gets at the exciting stuff. It starts to look at how do we make this a market-based process so that there are the right price signals, the right price responses to customers, so they're making the right choices. So whether somebody in the future decides to put a no export system on, which is called a self-supply in the docket, so they just serve their own load, or if they want to participate in the grid, they understand the market conditions and they know what might be different about that compared to the current net energy metering process.
Yeah, we talked about that some time ago, about we didn't call it this because I don't think the word export was in use yet, but a no export idea. In other words, the guy wants to put photovoltaic on his house. So he just puts it on his house. And he needs backup from you. He needs to be a customer, a member, whatever.
Right.
And be able to draw down from you, say, during the nighttime.
Right.
But he doesn't have a need to sell to you. He doesn't have to export it all. He doesn't care about the credit, whatever. I mean, the NEM, net energy metering.
That's right.
Energy credit, doesn't care about it. And if that's the case, then there's really no stress on the system, right?
There is a little bit, and I think one of the things that's often misunderstood is that a system that doesn't export has no impact on the system. If a system doesn't export and you had a bunch of those in the neighborhood and they're all taking all their load off the grid all at the same time, it still has the same effect as larger, fewer systems that export to the grid, in a sense, because they're taking all the load off. Now, what we propose,
and if the sun goes behind a cloud,
yes,
you get a sharp change.
You do.
And you have to have the technology to deal with that.
The great part about these non-export systems, though, is they can be spread around and many more people can have access to rooftop solar, and they can use that to offset their own home usage. Now, even though it doesn't export, it still has the same effect of the retail rate, because you're offsetting your load in your home that you would have paid the retail rate for. So we think it's a very efficient model, and it complements the grid supply option for people who want to choose that. Now, most people will want to choose some kind of storage option to go with it. Storage is still pretty expensive, but I think as that technology gets cheaper and cheaper, more people will choose that option.
Storage. This is a good time to take a break.
Okay.
When we come back, let's dive more into storage,
Okay.
as part of this. That's Jim Alberts from Hawaiian Electric. We're here on Hawaii, the State of Clean Energy. We're talking about a future of distributed energy resources to be part of the program at the convention center called APCES, I'll call it that. That's the Asia Pacific Conference for, Clean Energy Summit.
Right.
Asia Pacific Clean Energy Summit. We'll be right back.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Hi, I'm Chris Latham, and I'd like to invite you to come and watch my show every Wednesday at 3. I'm interested in a variety of issues that have to do with politics and our local business economy. And I'd like to bring on guests who like to talk about everything from technology to social media to what we can be doing to improve our environment. And so I'd like to invite you every Wednesday at 3 to stay and watch my show here with ThinkTech Hawaii. And I'll see you there.
Okay, we're back. We're live exploring the universe with Jim Alberts of Hawaiian Electric, talking about the state of clean energy, a future for distributed energy resources, which is really the issue of the day, I would say, more than anything else right now. So storage, we left this cliffhanger discussion on storage.
Sure.
So we've had some experiences with storage. There are some new products. I saw something in the email yesterday, this morning, that Blue Planet Foundation is selling storage. How do you like that?
I hadn't seen that yet.
It's extraordinary. So it's just like Tesla. People realize that the guy who invents household storage is going to make Bill Gates look like a piker.
Right.
And same with Musk. And although I think he's going to invent it faster. But that's the big issue. And, I think there's going to be all kinds of people in the marketplace doing that. And the question is whether we can afford it and whether we can integrate it with the other technology and who puts it where.
Right. I think if we think about storage broadly, which we have to, it's just like any other resource. It's got to be diverse in order to manage the risk properly. So I think in the end, we'll see a good mix of storage that is on the utility grid, and we're going to see some storage behind the meter for customers, battery storage, and then you'll see some other storage today that exists, like thermal storage using water heaters. So there's some really great low-tech ways that people can implement today to save money and not have to invest, make that choice today with batteries, because it's a big investment and it's got to last a long time in order for it to pay off.
Yeah, that's I referred to it in the break as the Deacon's Chariot. If we all buy the same kind of batteries on the same day, we can expect they'll all fail on the same day.
Yep.
And then we'll have a community issue about that.
Yep, we really will. And I think, the other thing that we have to consider here that might be different elsewhere is it costs a lot of money to import those batteries, and when those batteries need to be recycled, it's going to cost money to export them too. So we need a way.
Say nothing of the landfill issue.
Right, and we hope they never go into the landfill, that they're going to be recycled and reused, which means we need to have some kind of system to track them so we know where they're at, so they don't end up in the landfills and they don't end up out in the ocean. Because the worst thing that could happen is people realize when they serve their useful life, they want to get rid of them, and they go ask how much it costs to dispose of them, that they think it's cheaper to just discard them. And we don't want that to even come through somebody's mind. We want it to be easy, simple, a service-based option that people just return their batteries into the rightful place.
You think batteries are the one that's going to, what did I hear yesterday from Mark Yamamoto, that there's actually a flywheel operating?
There are. Flywheels have been around for a long time. It's a great option. It can serve the grid really well. And that's why I think when I talked about diversity, it's hard to just spread one solution out and say it solves everything, because it doesn't. Flywheels can solve a problem. Storage behind the meter can solve a problem. But from a homeowner's point of view, they don't want to think about all those technical questions. They want to buy a solution. So if they want to buy a certain level of power quality or a certain price, and a battery is part of that option, I think most people would want to consider it as a package. And the homeowners, I think, are going to think about this, not just their electric bill, but they want to start to think about this as their whole home energy bill. So not only are we thinking about electricity, but we're thinking about their vehicles, electrification of transportation. It's the whole household energy bill now that we need to really focus our attention on.
I have this vision of a store, a department store, multi floors. And in the store, it's got everything. And, and some of them are concessionaires.
Sure.
Some of them are, direct sales, who knows what. It's a retail hardware, department store. And it's hardware, software, it's all kinds of renewable possibilities, all kinds of gadgets for efficiency. It's all kinds of batteries, all kinds of inverters, assuming there's opportunity to have more than one kind. But going forward, even if we don't have a physical store, it's just a catalog or a website
It
where you
is.
can make your choices, see the pros and the cons, push a button, and it happens.
Right. I think you're not too far off from the end state, actually. Now, the choices are many and the choices are complex. So I think our role is to help people make those good choices from an objective point of view. If you look across all those alternatives and people are coming at you one at a time and you're trying to make a decision, how do you do that? Because these, I mean, you're making a 20-year commitment here in many cases. So making the right choice that's going to live that long and it's going to actually deliver the results that you thought it could deliver is a big issue.
How are we going to get there, you know? I mean, there's been discussion about these things on ThinkTech, but everywhere, at Clean Energy Day, Energy Policy Forum, for, gosh, I don't know, several years.
Right.
And, you know, everybody has the idea that it's right out there, but we don't quite have it yet. How do we actually get it? What stands between us and getting it? If you say, don't take the technology because there might be something better later,
Right.
you may be losing out on something somehow. It's like me, I buy the computer right now. I don't care what's coming down the pike. If I need it, I buy it.
Right.
So what can we do to actually what you call it, the end state?
Right.
What can we do to get there?
Well, it's like most technology changes. You're going to have the early adopters like you that embrace it no matter what it might cost, just to try it out. And we learn a lot from the early adopters. And from there, it turns into the mainstream groups. But I think getting the right protections in place to help people make those decisions, I mean, a 20-year decision around a energy system is almost the same as a mortgage. Mortgages might be 30 years or longer. So you think about the same things people ask in that process. Maybe you're going to have some insurance products start to develop that help people take risk out of the equation.
Yes.
You're going to have some consumer protection that gets developed around this decision process.
So that you don't get sold a bill of goods.
That's right. So if I go buy a used car and it's $3,000, I get a truth in lending agreement put down in front of me, and I know exactly what the costs are right up front, and I know what my warranties and guarantees are right up front. So as you start to take risk out of that equation for customers, they'll start to take more chances. But it is true, you know, if there isn't anything there, people will always be a little bit resistant to make that choice.
Yeah, I mean, you can say that there's, what do we have now, 10, 12% on solar, but this 80%, 90% that didn't do it.
Right.
And that's for a reason, not just money or the fact they're in a condo. They didn't do it because they have reluctance at some level.
Right. Now, one thing you just mentioned about the numbers there that I wanted to point out, they've gone up. So now we're up to almost 16% of our customers. We have 70,000 customers that have either installed or been approved for rooftop PV.
70,000 out of?
450,000 total customers. Now, if you break that down and you look at just single-family homes, which is the target market for rooftop PV today, single-family homes, on Oahu, it's a whopping 30% of all single-family homes have rooftop PV. It's a staggering number. And back to your earlier question about technology, that means all those homes have potentially technology that are going to have difficulty integrating into this grid of the future. So there are going to be some retrofit costs, and we're going to have to look at how we take advantage of opportunities to change those.
Yeah, it's complicated.
It is.
And it's all within this distributed energy resource question.
Absolutely.
Which is coming up at the APCES in the form of a panel, which you are one of the panelists. I'm the moderator. There's, 4 other panelists?
Right.
Let me try to remember who. Mina Morita's there. Marco Mangelsdorf is there.
Warren Bohlmeyer.
And
myself.
Is that it? Okay.
Yep.
4, 5.
And Mike Yamani.
And Mike Yamani from KIUC, 5.
Right.
Yeah, good panel. And what is that panel going to be discussing? I mean, in general, if you could. I mean, I would expect the issue is, what are we going to do about this docket? What should we do about this docket? What are we going to do ultimately about distributed energy resources? What are the challenges? What are the options? What are the possibilities? I guess that's what it is.
It really is, and it's framed in the backdrop now of our statewide goal of 100% renewables. So if we know that's the end state, it's really a function of what's the best way to get there. And we know that distributed resources are going to be a big part of it. So each of these people on the panel have a unique perspective and a diverse perspective because they represent all the way from solar company owners and installers to large commercial contracts to KIUC and us as utility members. So it's going to be a diverse discussion. We're going to have differences of opinion for sure. So I encourage everybody to come out. I think it'll be a lively debate.
Let's, on that note, let's take a short break and we'll come back and I'll answer some of the questions that occur to me about those issues. That's Jim Alberts with Hawaiian Electric here on Hawaii, the State of Clean Energy, a future of distributed energy resources, the question of the day. We'll be right back after this short break.
Aloha, my name is Jim Shawn, and I'm host of a show called Education Movers, Shakers, and Reformers. Each week, live streaming at noon on ThinkTech Hawaii, we interview people who have special insights into education from early education through K-12, all the way through higher education and beyond. Both public and private are areas we're interested in. We dig deeper. We try to find out what it's really like to be involved in making change, advocating for it, how you reform, what people's philosophies are in reforming it. As I said, we're live streaming every Wednesday at noon on ThinkTech Hawaii. And later on, you can find these interviews on YouTube and on the Hawaii Educational Policy Center website. We hope you join us as many times as possible. Aloha.
Jim Alberts, thank you so much for coming down. I really enjoyed these discussions.
Sure.
It's an exploration to try to find, the parameters and help us in our thinking. Jim Alberts from Hawaiian Electric here in Hawaii, the State of Clean Energy. And today we're talking about a future in distributed energy resources, such as to be discussed in the panel program on August 24th at 1:30 at the Hawaii Convention Center.
Right.
Yeah, be very interesting. Okay, so where were we then?
Well, one of the questions I think we're going to grapple with as we look at this clean energy future and we go through this transformation from where we're at today to where we need to be, there's going to have to be some spending to get us there. So even in terms of upgrading the grid, because in my opinion, we can't get to 100% renewables without a grid. You think about a diverse set of renewables with wind and all these resources, you have to have an efficient way to bring them together to make sure they're usable by people when they want to use them. And then the second piece of that is the cost. So today, one of the regulatory policies is cost causation. So if you're the person that creates the upgrade, you have to pay for it. Now, I don't know what the right answer is or where it'll end up.
Creates mean?
In our new future of pursuing 100% renewables, is that really in the interest of everyone? So we share those costs evenly across the entire customer base in order to get there. And there are some really good arguments on both sides of that. And that's what we count on, that there are good arguments on both sides, so we hear all the issues. And the state and the PUC can make the right decision that way. Because it really is going to boil down to what's in the best interest of customers, which the PUC ultimately decides in this case. So who pays, and even programs as to where you deploy things like storage. So can you deploy storage on the grid? Certainly, that's one option. Can you deploy it behind the meter? Yes, that's another option. But we still have to integrate all these resources. So even with storage behind the meter, if we put it there.
That means on the Hawaiian Electric side of the meter.
On the customer side.
Customer side of the meter.
Even if it's there, there could be a future opportunity for a customer to provide a service to us. In the case of an evening peak and their battery's fully charged and they want to provide that as a resource to us, we would pay them for that. But in order to do that, we have to have that system that knows.
When you ask.
When you ask, is it available and can they export?
Yeah, I mean, this goes back a year or more, but we were talking about the possibility of having a black box where Hawaiian Electric or whoever the utility was would say, we don't want any more power. We don't want any more. Don't send us power. And we'd be
Right.
able to cut them off. You say,
Right.
you know, flip the switch, no need.
Right.
But actually, it seems to me that logically, it's better for you to say when you want the power.
Yeah, that's right.
Instead of having to spill it, you
And-
know.
And it works both ways. I mean, curtailment and wasting energies might be the most cost-effective in the short run, but in the long run, we don't want to waste renewable energy. Now, there's a lot of work to be done in the phase 2 of this DER docket with pricing and things like time of use rates. If you look at some of the wholesale markets in the mainland, for example, if transmission lines are congested, they actually have a negative price for power. So if you're going to put power onto the grid during those times of constraint, you have to pay to do it. So
Or
think of
spill
that.
it, or spill it.
Right, so you choose, you know, if you're the person that's contributing, you make the choice whether you want to do that or not. And if you want to do it, you have to pay somebody to take it. Now, that's a far-reaching scenario, but it comes back to the principle of a market-based design. And if the pricing signals are right, and we're doing that in the right way, then that's a good thing.
Yeah. Well, this comes to that last significant point of discussion, and that is software. You know, I remember when Better Places was viable. I forget his name, but the guy came around. It was quite interesting, and he had this vision. In fact, I remember they talked about it, putting it in Grosvenor Center and Pacific Guardian Tower, and it was going to be this big kind of control room affair, and they would know who among their customers in the electric cars would be parked and connected up. I mean, this was really
Right.
pie in the sky at the time. I don't think it was a prayer that they could actually do this. And they would know who was connected up, and they could charge for the charging, or they could use the power in the car
Right.
as a huge, big collective battery and all that.
Yep,
And, you know, that was really, and he had been, the guy running this company had been with SAP, which is a big software house in
absolutely,
Europe.
right,
And his whole orientation was programming.
right,
And I believe from that, and, you know, from my knowledge of programming, that at the end of the day, you take all these various elements, hopefully they're consistent and they talk to each other, but then you make it work
yes.
with software that does things that you and I cannot even imagine what it could do. And you keep on evolving that and making it better and better and better. And after a while, it is smooth as silk for everything. I mean, over time.
That's right.
But the question is, you know, and if we talk about the special sauce for Hawaii, seems to me that the software is an essential element of that because of our special situation.
Yeah, the software is going to be an important part, and it's just like a computer. You don't want to buy a new computer every time a new piece of software comes out to make it work. So the software has to work the same way in our future, just like it does for computers today. So if we just keep modifying the software, it's a lot cheaper than going out and changing out all the hardware that's out in the field.
Sure, it's like an automatic download. It happens, and nobody has to do anything.
It is. Now, here's the thing that has to change, though. Today, there aren't really good standards around all of that. So for all of these devices to be interactive on the grid, that we're going to have to work at some common standards so that they'll all play well together. Because if they don't, or if they're all unique, it's very expensive to try and integrate them all. So the collaboration's important. I think in Hawaii, we've done a great job of collaborating with many parties. So as we worked with people like NRail, Solar City, and Enphase, and others, to make sure we're taking advantage of smart inverters, all the technology that's there today, that's the right way to go about this.
But somebody has to establish a standard.
Yes,
And my sense of it is that this is not nationally established at this point.
right,
Some things we have standards, like charging stations, there's standards for that, but not for inverters. And somebody's coming up with a new idea every day, and there's just no way to, you know, to freeze it.
right.
Can we do that here, do you think?
Yeah, and the hard part for us, which we already see happening, is that compared to the rest of the world, we're a small market. Even though we're a leading part of it, everybody looks down the road. If you owned a business, you'd think the same way. You look at California, it's a much bigger market. So let's design our inverters standards to work there first. And then, Hawaii's got to figure out how it works for them. So part of this discussion we're having with all of those players in the inverter industry and the local companies is, how do we make it flexible enough so it can be changed a little bit to work in our environment better? Because the standards that work in California on a really large transmission-based grid aren't the same needs that we have here. So we're gonna need the flexibility to be able to modify it slightly.
Yeah. Strikes me too that, we were talking about this yesterday, is that that Oceanic Cable is installing new, higher functionality digital boxes for your television. And what happens is you get a cardboard box with the new one in the mail. It comes, and you install it and you send the old one back.
Right.
And it comes from them, and they pay for it, and that way they achieve a kind of consistency.
Right.
And they control who has what at what time. They know who has what at what time, so they can help make things work together. It strikes me that one option, who's to say you will know a lot more about it, but it strikes me as the same approach could go here. It's time for your new inverter, Jay. Here it is in a cardboard box. Install it and make it easy to install, right?
Right.
And now it's installed, and now you know it's installed, and now you can put me on your software system to manage all of that. And you're paying for it. Actually, I'm paying for it at the end. But you're not charging me for this, not directly anyway.
Right.
That way you're controlling the technology, the distribution, the activation of this box. And I mean, maybe it's a page out of Oceanic's book.
It could get to that someday, and hopefully it does get that easy. The thing I would worry about personally is the safety aspect of that. So somebody.
Sure, you got a voltage there.
Somebody going into higher levels of voltage that could really hurt or kill them, we'd want to make sure there's a safe process. So maybe a better way to get there is to do this as a service. So rather than buying this inverter, it's some kind of a model where you have a service. If, just like with your cell phones today, if there's a better option or a better model that comes out, you can go get a new one. It's a little bit more money, but you don't have to wait for 20 years before you change it out. And kind of along the same lines we talked about earlier of what holds people back. The cell phone companies have figured that out. They offer options for people to do upgrades along the way without spending a lot of money.
And those upgrades are coming sooner and sooner, but they always have a legacy arrangement.
They do.
You never lose track of your data, and it's always a soft touch to move from step one to step two.
Right. So it has to be, the future for us and the future for the whole industry has to be a very customer-centric alternative. So the customer's got to be at the center of all of this planning, and that's how we have to design these programs.
Yeah, but there's another thing too, seems to me. We got to be together.
We do.
Everybody's got to be on the same page. We were all on the same page in a sort of gross sense in 2008 when the agreement was made. But since then, we're not on the same page. A lot of kuleanas and a lot of silos, and a lot of, lately, it seems to me, a lot of argument. Everybody's got an argument. And I'm sure we're going to see more of that going forward. But it seems to me we're not going to be able to do the stuff we need to do as a collective society in Hawaii and find our special sauce and make it work and make it resilient and make ourselves self-reliant as a state until we get together on things. And argument doesn't help.
No, it really doesn't. We've had some flashes of collaboration where we've done some really great things, but when it comes to the economic side of the discussion, everybody wants to look at their own interests. So today, the only way to do that is file with the PUC, and that puts a huge burden on them to have to evaluate all these options and make decisions. So I think they have aspirations for us as well to collaborate and set aside some of those personal issues.
PUC.
The PUC does. They want us to set that aside.
Their job would be easier, wouldn't it?
And it'd be easier for everybody, because think of the day in a docket, if we all came in and said, here's the 90% we agree on, this 10% we don't, but here are some alternatives. I would love to see that day, and I would love to work with a group of people around the community to be able to do that. Because when we don't do that, the only people that get hurt are customers, because they see a delay in the alternatives and options that are available to them.
One last question, and then we're going to be out of time. We're talking about innovation, we're talking about, product development, we're talking about picking the best options and making a uniform system for Hawaii somehow, relatively speaking. Where does the NextEra deal play in all of that, which is up in the air?
Right.
Where does it play?
NextEra is a great innovative company. And I think as we get further into this, should the deal get approved, we'll be able to get that expertise to help move these issues along faster. Their arm that focuses exclusively on renewables has probably looked at a lot of these issues, and I think asking them to help come in and help solve some of those will speed this up. And they're a much larger company too. So just like we talked about customer taking risk, it helps a company size from a credit management perspective be able to think about risk differently than if you were to make a small investment and it was the wrong investment and you lose your credit rating. So for a utility, the credit rating is critical to be able to borrow money for these big investments at the lowest possible cost so customers get low prices.
We'll have to leave it there, Jim. It's been great to talk to you as always. I really appreciate you coming down.
All right, thanks, Jay.
Thank you.
Appreciate it.
Jim Alberts, Hawaiian Electric.